Hi everyone, my name is Anisha Suri, and on behalf of Ideas, I welcome you all to the webinar for today. And we are very honored to have amongst us Professor Jerry Power, who is the Executive Director of the Institute for Communication Technology Management at the Marshall School of Business at University of Southern California. Welcome, Professor.
Hey, hello, how are you?
Hi, thank you for joining us today and for taking out time to share the views on the innovative IoT data management systems, which is the need of the hour. And before we begin dwelling into the IoT management systems, I would like to introduce you all to IDEAS, the International Data Engineering and Science Association. And we are a non-profit organization devoted to bridging the gap between academia and industry in the fields of machine learning, data science, artificial intelligence, blockchain technologies, and Internet of Things. Yeah. So we began in 2016, and we have come a long way organizing data sciences conferences and blockchain conference and different kinds of hackathons in different cities here in the US, in Chicago, Dallas, Harvard, and Los Angeles. We had a conference in October recently. And speaking of the blockchain hackathons, we doesn't move my slide. Yeah, anyway, so for the hackathons, we had one recently in New York last month, and this weekend, like the previous weekend that went, we had one in Dallas, and these are like really huge success, and we saw a great number of participation. And so as a concept and ideas, we are trying to bring in the different enthusiasts, the data enthusiasts, machine learning enthusiasts on board, and we aim to keep growing and spreading the knowledge overall. So without any further ado, I would request the Professor Jerry, who you can like start your discussion. Thank you, Professor.
No problems, no problems. Let's pull up my screen here. Can you see the screen okay? Can you see the screen?
Yeah, we can see the screen.
Okay, sounds good. Okay, so we're going to talk about I3. This stems from some of my work that I've done with the Institute for Communication Technology Management. CTM is really a think tank that looks at technology from a business school perspective. It looks at how technology is changing the way we think about business and how business is changing the way we think about technology. A lot of the work that we have done of late has been sort of focused on IoT. IoT, we think, is one of those disruptive technologies that has significant potential to change the way we think, work, live our lives. There are other technologies that are equally impressive, the things that are going on in artificial intelligence and data analytics, the things that are going on in data lakes, the things, how we're changing the communication networks. These are all sort of, when you think about the changes in all of these areas, each of them being significant, when you put them together, they actually have a compounding impact. And that what we want to be able to do is eliminate the friction so that more data can flow through that stack, that intelligence chain. We use that data then to analyze it and drive action, and it becomes sort of this cycle, whereas we move from looking at AI and data as sort of looking at historic information and predicting the future, to one where we can actually get a digital representation of our physical world and actually begin to use that same intelligence, that same infrastructure to drive operational changes to the world that we're currently living and experiencing. So it's a fascinating time to be in the area that we're in. And that's what we're all about with I3, is how do we try and reduce some of the friction that happens within those layers. Now, I3, when we put it together, the goal was to really sort of try and find ways to increase, to accelerate IoT adoption. If IoT is adopted more quickly, there's more data that feeds into that ecosystem we just talked about, and that means the benefits that come out of this can be accrued more quickly, more rapidly, to the betterment of everyone. Now, to do that, what we need to do, one of the things we came to the conclusion is that we need to make the device owners much more active participants in the process. If they sort of feel themselves as an appendage to the larger process rather than an active participant, they will slow down what they're doing. To make them active, we need to think about things like trust, privacy, security, and how do you do this sort of in a distributed nature? And that's really something that people are just starting to think about, but trust really becomes a really critical operational component. And how do you get people to sort of trust a much larger network? So that's sort of what we're trying to do with I3 is create that environment where people are involved and trusting. Now, today, if you think about what's going on in smart cities, smart communities, there's a lot of activity going on. I'm not taking anything away from any of it. When you have a good application and you have a need you're trying to solve, you deploy the devices, they drive the application, and wonderful things can happen. This is all great and to be lauded for what people are doing. But when we look at it, the devices, unless the devices can be completely justified by the value of the application, there's a lot of really valuable device applications that are not being deployed. If instead of having this siloed structure where devices drive applications, we move to more of a network-centered structure where a device can drive lots of different applications, that puts us in an environment where the device deployment costs are justified by not just the value of a single application, but by the value of a bunch of applications. And that lets a lot more IoT applications suddenly start to make sense from a return on investment perspective. The other thing that happens with this network perspective is that the applications are able to more readily see and get data from other devices. So the more data that they can pull back into the device, into the application, the better the decision-making process. The better the decision-making process, the greater the value of the application. So effectively, by moving from the silos to this network-oriented structure, we radically change the way we think about IoT systems and the economics behind them, and that is what enables the acceleration of the IoT deployment process. Now, how do we get there from where we're at? I mean, you can't just sort of put that networking structure in there and expect people to use it, because the people are all independently owned that own the data. Right now, a lot of work's being done in the industrial Internet of Things. In the industrial Internet of Things, you have a strong IT department that can set standards, say here's what can be deployed, here what can't be deployed, here are the rules we're going to follow, here are the policies. In a much more open network where each person owns a set of IoT devices, but they want to pull the data from the devices and participate in a much larger network, you actually have to look at each of those people as IT administrators of their own little device, their own little domain, which is controlled and being pulled together. In some ways, if you think about this as a Metcalfes Law kind of issue, we're basically trying to apply Metcalfes Law into the IoT data sphere. Now, for that to happen, people are going to want to feel that they have control of their data, and they're going to want to be able to specify whether the applications have read access, whether they have just limited access to certain parts of the information, whether they have full read-write. But having those people who own the devices have an active voice in the process is what makes the difference between this kind of a structure and more of a siloed structure where the data is given control to an application and you trust the application developers to sort of disseminate the data. Instead, we want to make the users an active participant in the process. Now, the other thing that has to happen besides giving them the rights to control and to manage their own data is that you have to give the users an incentive to participate in the process. And that means that really, and I say incentive, if look at the slide that is showing on the screen, it has dollar signs, and it could be dollar signs, but there could be like sort of a point system like airline miles. They do frequent flyer points. There could be coupons that are sent back to the owner. So effectively what you have is this process by which the owners are contributing their data to a much larger ecosystem, but they're actually getting some reward back as part of the process. So that transfer of data is actually really a form of a transaction where data is given and some acknowledgement is given back to them as a thank you for what they're doing. Users can change their permissions. They can change what they're asking for if they feel like their trust is being violated. So trust is not a black and white kind of issue. And actually, we look at incentives as sort of being a variable grayscale, something that counterbalances that trust and permission scheme the other way. So it gives sort of the applications and an incentive to actually provide properly and to follow their data procedures. But at the same token, it gives the users an incentive to sort of maintain and keep their data up to date and accurate. So the incentive mechanism actually kind of works both ways to sort of build a more balanced ecosystem in the IoT sphere. Now, I mentioned trust as being a critical component. If an application wants to gain access to a user's data from their device, they actually have to request permission, and the user has to sort of say, yes, I agree, I'm going to give you my access to my data. But part of when the application asks for access to the data, they provide things like the data policy, the usage, whatever documents they need to sort of gain the user's approval of their use of the data. The documents that they give back and the policies by which they live under represent sort of, do you trust the user, the endpoint, to sort of validate and to follow their policy. This is different than sort of the blockchain trust, which is really a question of trusting the communications channel as much as it's a question of trusting the endpoints and their integrity. But there needs to be sort of a crowdsourced way of sort of managing that trust so that people say, hey, this person has a good reputation, you can trust them. And at the same token, on the application side, there's a trust mechanism that sort of says to the users, to the applications, this is really good data, you can trust that it's been validated and verified. So that you need to have that balance in the equation as well. In some ways, you can think of this, and we have depicted it at times as talking about this as the Uberization of data. In Uber, you think of it, people buy cars that a lot of times they're not fully utilized. They're sitting in their car, in their driveway. And what you want to do is be able to let people use that spare time when they're not driving their car to go out and be earning money kind of on the side and utilizing that information flow. In IoT, if you think about the data that your devices, if you deploy an IoT device, it's constantly generating data. If you can use that data to help provide value to another application, that's a good thing. So what you want to do is sort of be able to maximize the amount that you share that data. So it is sort of, in a lot of ways, the Uberization of data. An interesting way to think about it. Now, what I'd like to do is spend a little bit of time talking about what this means sort of more physically and what this means. And this is actually a project that we've been working with the city of LA on. The idea here is that we would put video cameras on sanitation trucks. And if you think about sanitation trucks, they drive over every street in the city at least once a week, picking up garbage. So they're actually a constant video stream of what's going on in the city. By putting video cameras on those trucks, you can feed the video back into a video analytics program that's actually trying to interpret and understand what it's seeing in the data as the truck drives by. What we've been able to do is train these video analytics programs to do things so that you can spot bulky items that are sitting by the street. You can spot vegetation that's overgrown, if there's a structure that's unexpected, or even just something that needs special attention. So by running this through these video analytics, the video analytic engine can trigger alerts that go to the various city departments, and they can dispatch crews to sort of take care of that situation. So this is, instead of trying to wait for a user to sort of use their cell phone and sort of do a 311, take a picture and Snapchat and send it to the city and start complaining about city services. Instead, we're mounting cameras on sanitation trucks and using that to identify things before the citizens actually even thought that this is a problem. And then expeditiously, despite work crews, depending on the severity of the situation. Now that same video system, if you think about the video that's being fed back, you can use it to analyze and check all kinds of other things. One of the things we've used is taking that same video feed, and we've actually retrained it to sort of spot graffiti that's on the street. So if you, from that same video camera, so one infrastructure deployment, you change the programming a little bit. Now you're sending alerts to the cleanup crews that take care of graffiti on buildings, on trees, on signposts. So that's kind of using that same infrastructure, that same video camera, but in multiple different ways to drive different city services. So it's a very interesting thing to think about how you can reuse and leverage that video. Now, another application that we're working on, a lot of people, when they talk about healthcare and IoT and healthcare, they talk about it in terms of how do I get the data from the patient to the doctor or to the hospital. But what we're trying to do is look at healthcare as a larger environmental issue that takes the community. Specifically, we're looking at elderly and disabled populations. But the idea is by using IoT, and instead of sending the information directly to the doctor or the hospital, we actually send it to the network of social services that are already on the streets and helping to support these people. We use these social service networks sponsored by city, county, .orgs. And we use these as triage resources. So the triage resources actually look at the data, look for anomalies and what's going on. Maybe they schedule a wellness check with somebody to physically go check on the person. Maybe they immediately send the information to the doctor or the hospital. And this serves as sort of a triage process so that not every bit of data needs to go to the doctor unless someone has said, hey, this is something worth investigating and looking at. It also breaks and sort of looks at the HIPAA, keeps the HIPAA data in a HIPAA environment and keeps the non-HIPAA data out of a HIPAA environment. So we sort of start thinking about healthcare not as a medical issue, but as a wellness, as a community-centric kind of thing. And how does the community help the community stay well? So that's kind of an interesting way to think about how this increased leverage of IoT data can actually do good in a city environment. This is a similar idea, and what we're actually doing here is trying to figure out what's the process in going through. If we think about family services, which are often like really, it takes a village kind of a view of what do you do with the data. How do we start trying to use the data from IoT devices to sort of manage the community resources that are around family services? It's interesting that the technology itself, if you think about being able to pick up alerts from smartphones and from alarm systems, from smartwatches, that's not like really latest. It's known technology. It's well understood. What we're really trying to do is use the ability to route and discern the information to the right resources in a way so that it can be coordinated across the services and the right services can be brought to bear on the right situation at the right time, instead of having a separate police IoT network, a separate family services network, a separate services network for education. But in some ways, we're trying to take those same devices and leverage the data that comes from them in a much larger ecosystem that plays at the data level. One of the things we've thought about is how do we start taking the data from individual small businesses, pulling them together and start thinking about them as a consolidated entity, as a business district. One of the things that large stores have an advantage over the smaller store is because that there's much more floor space, they have more products, but that also means that they're collecting much more data and using that to sort of improve their ability to market to their consumers. Now, if you start and take that same technology and try and boil it down and apply it to a small and medium business, it becomes problematic because the infrastructure costs, the fixed costs are so high compared to the value that comes out of that single entity. But if we can take the data from lots of stores, pull them together in a way that sort of respects the store's integrity and their ability to manage and oversee their data, but then pull it together, we can treat a whole business district as though it's a single large store. And therefore you get economies of scale in terms of being able to do the data analytics and even the data storage. So some real interesting, fascinating opportunities here to change the way we think and look at small businesses and the way that they operate in a data-driven ecosystem. Now, one of the things that we've spent some time thinking about is this idea of and I'm going to say emergency services. The city loses track when emergency services people go into high-rise buildings. They often know, like X and Y, that their emergency services people are inside the building, but they lose track as to what floor they're on. Technically, this is not a difficult problem to solve. You could put beacons or other local sensing devices on each floor, and you could tell where the emergency services people were, and which is a great help for the emergency services crew. However, it's expensive to sort of do that, to visit the floor and equip each floor with each technology. Certainly, the city often is constrained in terms of how much financial resources it has, so their ability to deploy it is somewhat limited. So the idea here that we're exploring is the idea of basically using IoT to sort of create a smart concierge, a smart building that's able to track people inside the building, whether those are residents or whether those are delivery people like the Domino's delivery person, but figuring out where people are, where they're supposed to be, make sure everything's operating. You can even put the IoT devices on carts and things like that. So here's this smarter building. Because the building's smarter, the landlord can use it. Maybe it makes it a little higher rent and he gets a little more for the rent, or maybe it improves his occupancy. Either way, there's a business benefit there for the building owner. At the same token, though, because this technology is now shared, when the emergency services people are called to the building and they go into the building as they go up and down the floors, the city and the emergency services people have view as to where they are inside the building. And that makes the city much more efficient, and safer for the emergency services people. Because the city can support the building better than it could without this technology, perhaps the city even steps forward and says, look, we're going to reduce the permitting fee if you have this technology, and here's a different permitting fee if you don't. So ultimately, what we're trying to do is get to an environment where basically the advantages of using IoT technology can be spread over a wide range of people, and it applies in this situation as well. Now, airports is a good place to sort of look at what we're doing and how this works. If you think about airports, airports contain a bunch of, well, first they contain a bunch of people who are flying to and from different places, so those are individuals. There's a bunch of retail stores and shops spread throughout the airport. The airport is served by different airlines. They have ticketing counters, they have their baggage claim people, etc. And there is a number of subcontractors who are catering the flights and doing that. So if you think about the structure of an airport, it's actually a very complicated city that is sort of self-contained into itself, an organization. Now, each of the organizations and people inside there, they're all generating data. All of that data has value that if it were pulled together and consolidated, it would give a better view as to what's going on in the airport and how do you do it. However, to get these people, everyone to participate in the process, there is always sort of this reluctance about who do I give my data to and who do I don't give my data to. If you have the people where they have the ability to turn on or off the data, if they have that control, they're more likely to share their data with somebody else because they know that they haven't given up control of their data forever. So we think that this is sort of a natural place to sort of apply these concepts that we're trying to build in the I3 Consortium. Now, We've also spent time thinking about smart cars and smart trucks and what does that look like. A lot of people do think about cars and trucks, and there's a lot of activity in this space. It's all really good activity. Typically, though, the person who's investigating it is sort of looking at it from a single perspective. That is, if you're a car dealer, maybe you're thinking all the data comes to the car dealer. If you're the car manufacturer, maybe you're thinking all the data comes to the car manufacturer. We're sort of taking the approach and we're thinking longer term, because that single approach might be ideally what you want, where all the data goes to Tesla and Tesla gets to analyze and do everything with it. But longer term, if you start thinking about the information as people become more comfortable with this kind of technology, it's actually a bunch of independent data streams. And that the data streams, the car owner is going to want to manage each device stream independently. That is, the entertainment stream that comes from the car, the same car, maybe it's the same BMW, maybe one person wants to get their entertainment service from Disney, another wants to get it from Warner Brothers. So you want to be able to have that in the user to have the independence to drive their data streams to who they want to do it to. And if you think about all the people that might have an interest in seeing some of the data streams, the vehicle dealer, the vehicle manufacturer, maybe there's an independent, the mechanic down at the end of the street, the insurance company, a bank, a leasing company, maybe there's a text and voice communication provider, an internet. If the car is part of a fleet, or maybe even the family has multiple cars and they want to manage them together, those are all independent streams that the user of the car is going to want to be able to control and direct where they go to. And every user is going to want to make separate decisions on each of those things. Not everyone's going to want to go to the same insurance agent. At the same token, a lot of the data streams that come out of these smart cars are actually related to city services. In some cases, the cars are going to talk directly to the cars on the street. In some cases, the cars are going to talk to the street itself and sort of get information from the city. Maybe they're sending out road repair crews and finding out where things are going. And maybe because there's an emergency, the city is going to reroute the traffic around the emergency to avoid a hazardous area. So at the same token, all the data that's going back from the city into the cars and from the cars to the city, those are all independently managed. We all know that not everybody's going to want to allow the same level of data interconnectivity from their car to these different people. So this provides a way to sort of give the user control and manageability, and that's what makes them more comfortable with the technology itself. Now, one of the things, and we're pretty early in sort of working our way through this, is that we're trying to figure out what is an IoT-based entertainment experience. And there's a lot of things that can be done. A lot of times when people talk about IoT entertainment, they're thinking about AR. It's like a theme park, or they're talking about VR experiences that might be happening in a mall. But really, we're starting to think beyond that and thinking not just about triggering advertising or content by where you are and location and demographics, but how big is the crowd around you? Maybe the entertainment content itself dynamically shifts itself. Maybe there's live entertainment events that detect local environments and can recreate that where you are, where you're watching it, even though you're maybe not at that physical location. There's lots of things that can be done, and what we're trying to do is sort of open the blinders, as it were, and instead of thinking about entertainment as a modification, a change in the way we know entertainment today, but we're starting to think about this IoT-enabled entertainment experience as really a new genre of entertainment that lets us do things that we've never even thought or considered possible or worthwhile before. So that's a whole new area of exploration of what this new genre might actually be and where it might be consumed. Now, it's interesting if you think about what we're ultimately trying to do. We're trying to basically eliminate the friction that happens between devices and the data stream, how those data streams flow upstream. Right now, if an application wants to do an IoT application, they have to make relationships with each of the users who's generating the data, maintain those relationships so they have access to the data and manipulate it and move forward. If we start saying that devices are able to freely put their data in a data marketplace, and make them available to people who ask for and receive permission to access the data. Then you can start imagining a day when data analytics entrepreneurs, people will sort of go in and sort of say, hey, if I take this kind of data, add it to this other kind of data, do some manipulation and do some value-added processing, I can create a new data set and offer that back into the market. So you actually can start doing crowdsourcing where the value of what you're doing is not so much whether you've been able to make relationships with the devices, but it's really in terms of understanding the relationship that exists between data. That in itself becomes valuable. And we think that creates a whole new class of data entrepreneurs as people start understanding how data has value and how they can use and grow that value. Now, the applications I went through, these are just some of the applications that we're working on. We're not driven by any specific city, county, or government agency, but what we're trying to do is explore and understand how leveraging data for different uses, different applications can actually increase the value and make it easier, quicker, faster to deploy these IoT systems. By going through and exploring these case studies, these use cases about how leverage can actually add value, we think we create a whole repertoire, a whole menu of opportunities that individual cities or organizations can pursue. Which opportunities make sense in which geography and which application varies depending on who the user is. This is an example of sort of a triage matrix that one of the cities has developed here in Los Angeles County. And what they're trying to do is sort of evaluate each of these opportunities, and they want to look at both the strength, weakness, the opportunities, and threats. And then as each of these operational scenarios goes through this triage filter, they'll use the triage filter to prioritize and focus their resources, which are city resources are limited. You want to focus them where they provide the most bang for the buck. But this is basically the process by which they'll try and go through and do that and prioritize the efforts to make sure that the citizens are really receiving value from what they get from the city. And that's kind of the process that we think other cities will go through. They'll have a similar sort of triage process. The answers that each city comes up with will be different, but if they all have access to data and the similar processes, the process of going through this triage and trying to figure out how to apply the resources for the benefit of my unique citizens becomes much easier, much more straightforward. So that's ultimately where we're trying to get to. If we can make and start eliminating the hurdles, we think that whole smart cities, smart communities environment gets accelerated significantly, and that's what we're trying to do. Now, if you're interested in I3 and some of the things that we've been talking about, we are trying to turn what we're working on, we're trying to turn it into open source software code so that any city could freely, any city, county, state, any government agency, and even a commercial entity could download and use the software in a way that benefits everyone. That's where we're trying to get to. The organization is really sort of in its beginning phases, but we do have several working prototypes of the software we've developed, and right now we're trying to turn it into something that we could release into the open source world. And if you're interested in participating in it in any way at all, you can find more information at i3.usc.edu, or just send an email to director@i3.usc.edu. We think this is a win-win scenario, and we think it sort of begins to make a game changer in terms of the way we think about IoT and what can be done with it. It really takes the blinders off the process. Some of the other things that we're working on, just kind of so you know, and this is a little telegraphing ahead as I close the slides here, but we do have on January 4th an IoT event here at USC in Los Angeles. On the slide, you can see the Eventbrite link, so feel free if you're interested in coming to click and go. The other thing that we're working on, we have a book scheduled for release the summer of 2019 about the RealTime Revolution. What we're doing is all this IoT technology and all the things that we've been working on, what we're really ultimately trying to do is make organizations more responsive from a time standpoint. And what we're trying to do is figure out culturally, how do you start evolving organizations to sort of understand, respect, and target their resources in a way that they're continually trying to improve the real-time relationship that they have with the customers or citizens that they serve. It's a fascinating book, and hopefully you'll all be interested, and when it comes available, you'll get a copy. With that, I've been talking sort of nonstop here for about a half an hour, so why don't we pause and take questions.
Thank you, Jerry. That was really knowledgeable presentation, and got to know about so much innovation that is going around, and especially the diversity in the use cases that you presented. Really learned a lot. And
good.
Guys, if you have any other questions, please feel free to ask him. And you can type it out and you can read it on.
Okay.
Do we have questions?
So while we're waiting to see if there are any questions, let me just say, because for those who have dialed in, or if you're watching this online after the fact that you're interested in this area, I think speaks well of you. This is an area that needs still a lot of work, but there's a lot of activity, a lot of benefit associated with it. I think it's an exciting place to be. So the fact that you're even interested shows that you're sort of looking forward and want to be a positive element in the change process that we're all going through. So I applaud everybody just for that.
Absolutely. Well, I don't see any question, but I have one question, Jerry.
Sure.
So is there something, like when we talk about Internet of Things, so is there something that shouldn't be connected, like which is not at all feasible or safe to be connecting? Like, or it can be like anything, because like, what are your views on?
You ask a really good question. Let me answer it in two ways. So the first way is that the way that I think about it, I can't think of anything that is not of value to be connected. There should be concern, there should be worry about if you connect things that are not well secured, or if you do not trust the source that you're talking to. So there are places that if you are at all unfamiliar, you're talking to somebody you're not sure of, that you need to be worried about. And there are concerns with that. But I think that ultimately, whenever you feel that uncertainty, that hesitancy, that means that there is something that is needed that is not in place. So it doesn't mean that it shouldn't be connected. It means maybe the tools aren't there that allow you to feel like you can connect freely at this point in time. And hopefully in the future, there will be less and less of those. The exception to that is, I know like some military networks, some other, they're totally isolated from the internet completely. And there probably are cases that are very specific where you do want to isolate the IoT devices completely from the external world. But whenever you do that, just like in a military network, if you isolate the network, you're sort of also, while you're stopping people from getting into the system, you're also precluding the system from getting out. So in the IoT space, if you isolate something, you actually have absolute security over the system, but it also means that now the data cannot be leveraged by yourself or other people as well. So hopefully over time, we're sort of still learning about what we should be talking to, who we should be talking to on the internet. And I think the internet's been there for 20 years and we're still learning. But hopefully we feel more and more comfortable of knowing who we're talking to when we talk to somebody on the internet. We will probably go through a similar progression in the IoT space.
Thank you, Jerry. That very much answers my question. And there's one question on the group. So Rishabh Hasija, he's asking, how can we use the software to check if it can be implemented in our respective cities? He's a bit unclear on that.
So the software, when we release it as open source, it's going to be released on GitHub. So we are not trying to restrict or there will be engineering guidelines associated with it, but we're not trying to restrict who can use it or how they can use it. We expect some people will download and run the software from a cloud. Some people will download and run it from a local server. We have even thought about some people wanting to run i3 nodes as a part of a business, as sort of a IoT as a service kind of structure. And we're not trying to restrict any of that. In fact, people can even download the software and incorporate it as part of a larger product. I know when we talk to the city of Los Angeles, they talk about at some point maybe having the city run some i3 nodes directly, where they want a higher level of security and assurance. Like for instance, maybe the police would run their own i3 node. But alternatively, for the Parks Department, which is a different entity completely with different privacy and security needs, maybe they would use i3 as a service and rent an i3 service node from somebody like Verizon or maybe a local vendor and run it that way. So it's pretty open the way we're trying to go with this, and we're not trying to sort of say, here's what you do or you don't do with it, as much as we're sort of trying to point everybody in a common direction. But by all means, we're early enough. We have not actually released the first i3 software yet. We have the proof of concepts, and we're trying to convert it into something that's ready for open source. But anybody who does want to participate in the process, the i3 development process, kind of like Linux developed with crowdsourcing, that's what we're trying to do with i3. And any city, organization, developer who wants to participate is free to add their voices to the choir as we're sort of moving forward with the process.
Thank you. I hope that answers your question, Rishabh. And yes, it does. So yeah. And if any other question is there, you guys can ask, and you can connect with Jerry and ask him personally also. And
absolutely. and I appreciate everybody taking time out of their Saturdays to do this with me.
Yeah. So thank you everyone for joining in, and congratulations, Jerry, on the book. It's really good to know, and looking forward to it.
Thank you. Thank you.
And thank you everyone. Have a great weekend. That's all from my end today. Bye.